Okay, this is part 3 of electrolysis, and what we're looking at today is electrolysis of aqueous solution when no halide ion is present. And basically, what we're looking at is, again, we've got this reactivity series where potassium is the most reactive and gold is unreactive. So if you remember, silver and gold are completely unreactive. And we have looked at two parts, which if you haven't seen, I suggest you go and have a look at them at some point. The first part is molten substances. The second one is aqueous solutions with halide present. And this is the final type of electrolysis that you need to be aware of, which is aqueous solution with no halide ions present. But it is aqueous solution as usual. So if we say, for example, magnesium sulfate. Now, magnesium sulfate, I gotta write AQ just to make sure that it is clear that it is an aqueous solution, right? And as you can see straight away, and we are now going to carry out electrolysis, which obviously involves electricity. Then what we do first is exactly the same as before. So we're going to look at the ions that are going to be formed. So we are going to end up splitting up magnesium sulfate into its ions. So it's MgSO4, and basically this will be split up into its ions. And the ions in this case, magnesium is 2 plus, and sulfate is going to be SO4 2 minus. So those are the ions for magnesium sulfate. And the second thing that we need to consider is water, because it's aqueous. So we've got H2O here, and that's going to be split up from H plus and OH minus. Right, so that's what it's going to be split up into. So we've got water splitting up into hydrogen ions plus your hydroxide ion. Then, as usual, we're going to look at the anode. It is positively charged, and the cathode is negatively charged. And the way to remember that is panic. So positive anode, negative is cathode. Again, as usual, what we're going to be looking at here is, well, what ion is going to go to the anode? We've got the anode is positive, so the only ions that can go to it is going to be the sulfate ions and the hydroxide ion. So only one of these two can go to it. Why? Because this has a positive charge and these ions are negatively charged ions. The question becomes, which one is going to go to it? Now, if you remember from the second video, the rule was the halide ion will go to the anode. However, there is no halide ion here, so what's going to form is the hydroxide ion will go to the anode. But what will form, again, this is something that foundation people will need to know. What's going to form at the anode is oxygen, but you, as higher, you need to be able to write the half equation. So what is the half equation? It's like this. So you got OH minus, and what that's going to form, as I just told you, is going to be oxygen. Oxygen is diatomic, so it's going to be O2. Now, we need to account for this hydrogen, and the way you do that is you add water. So we need to have water on this side as well. That's just to account for the hydrogen on this side. Then what we need to do is we need to balance it. So you've got one oxygen and one hydrogen, and we've got two oxygens here, and we've got two hydrogens and one oxygen. Now, the easiest way to do this is to make it in multiples of 2. So what I'm going to do is I'm going to add a 2 there. So we've got, in total, we've got now 4 hydrogens and 4 oxygens. And so that makes it a lot easier to balance. So we're just going to put a 4 in front of the hydroxide ions. The atoms are now balanced. The final thing to do is to balance the charge. So you got a 4 negative charge here, and so on the opposite side we also need a 4 negative charge, and so we're going to add those 4 electrons, and because we are losing electrons, this is oxidation. And then what we have here is the cathode. Now, the rule for the cathode was explained in video number 2 of this series. But what we're saying is that the one that will go to the cathode is the hydrogen ions. So the hydrogen ion is definitely going to the cathode. And what does it form? It will form hydrogen. So that's H2. Now what we need to do, as usual, balance the atoms. So this is 2H plus. And then finally, balance the charges. So we're going to have 2 electrons here. And because we're adding electrons to this process, this is called reduction. Then we need to consider the final solution. So what is the final solution here? So again, all we do is we cross out what we've used up. So in this case, we've used up this bit here, and we have used up this bit here. So we're still left with magnesium sulfate. So we're still left with magnesium sulfate in this instance. Right. Now, where is this useful? It's useful when we have something less reactive than hydrogen, which is copper. So let's have a look at copper, and really copper would be what they would ask you for. We're going to go to copper sulfate, and we're going to carry out extraction of copper from copper sulfate, and we're going to do exactly the same thing. So the first thing is we're going to look at the ions. So what are the ions involved? When electrolysis happens, it will split up into its ions, which is going to be Cu2 plus SO4 2 minus. Then we must consider the water because it is aqueous, and what's going to happen here is you'll have your hydrogen ions plus your hydroxide ions. So that's what you're going to have. The next thing now we need to look at is the anode. So the anode is positively charged. Ions can go to the anode, so it's going to be the negative one because the negative will be attracted to the positive. Right, so what's going to go? Is it going to be the sulfate, or is it going to be the hydroxide ions? The answer is it's going to be the hydroxide ions. Why? Because there is no halide ion present. So we're going to have OH minus going to the anode, but what's it going to form? It's going to form oxygen. Then we need to balance this hydrogen with water, then balance the atoms by putting a 2 in front of there, which means that we've got 4 lots of hydrogens and 4 lots of oxygen. So we balance that with a 4 on the opposite side. Now balance the charges, it's going to be plus 4e minus. And that is, again, of course, we're losing electrons, so it's oxidation. Next is the cathode, which is negative. And in terms of this negative, we've got one of these two that can go. So remember, it's going to be attracted, the positive ions are going to be attracted to the negative part. And so we've got copper ions and hydrogen ion. And the rule for this one, if you remember from the last video, is the least reactive ion will go to the cathode. And in this case, it's going to be copper. So we've got Cu2 plus, and it's going to make copper. Now they are balanced in terms of atoms. You just need to balance it in terms of charge. And so that's going to be 2e minus. So what's the final solution going to be? The answer is just cross out what you've used up. So we have used up, in this case, the copper, and we have also used up the hydroxide ions. And so what we're left with is H plus SO4 2 minus, and that's going to make H2SO4, which is pH 1 because it is an acid. Acidic. And that is the final part of how to carry out and understand electrolysis.